Okay, things seem to have started. Very good. Um, okay, I should probably also edit the name of the setting up CI. My start project. Save. Right, seems like a good a title as any. So what's on the docket for today? So I have this I have my project here. Yes. So what is the story? So this thread, apparently I started this thread when I was like not being able to update my code and it was being very annoying. But at some point, Kim mentioned that, right, so what I have not really there I'm aware that there's like CI tools for like lean projects that, like, so MATLAB obviously has like very comprehensive continuous integration that makes sure that you can't like push things to master when they're utterly broken. And I'm aware that these tools exist and can be used like for other lean projects as well. I have never really gotten to the trouble of setting those things up for my projects because it's always like, many of the like things in those projects are often broken anyway. And so it's sort of like, oh, okay, the project's going to be broken anyway. What's the point of like having CI, complete, like constantly failing and telling me I can't do that? Um, but maybe like apparently there's some way of like only checking certain files, which might be useful because there are some files that I think, should generally not stay broken. There's like basically, right? Basically, it's the like set of files that I'm like trying to upload or trying to pull requests to MATLAB gradually over time. Those are files that I basically want to not get broken, and I'm always like pretty careful to sort of make sure they're not broken whenever I do an update. Um, and so maybe something can be done to add those files to continuous integration. So that seems like a good decision. And this is where I was told that that's the case. It's the case, right? So there was this pull request, or no, what is this? This is a lean for issue. It's just a lean for issue that says that Lake should give a warning when nothing is imported by accident. I don't know if I'm like, frankly, I don't know if I'm like entirely in favor of this pull request because like what what this is saying is that it would error on my thing, but I don't want my thing to give me this warning. Pretty common user error in a project foo is to neither modify foo.lean to import their interesting files. Like, why is that an error? I do not modify foo.lean in my project, and that is exactly intentional. Their lean lib. It's only discoverable. Just leave with the default contents. Yes. Lake build is essentially a no up. Yes, sure. Import modules that should be built as part of the lib. Okay, the default template now says this. You should just switch the default lakefile.lane to use globs. The setting causes build foo to build all lean files in the foo directory. Right. Automatically updates foo.lane. Okay. Well, yeah. This is not like particularly relevant to me because I will just have to do this on my own. Right. Currently you have to write, copy, paste. Okay, so how do I do this? The question is, I want to set up continuous integration. You have to write / copy paste your own GitHub action around a lake build. But Austin Lutson has been working on lean action. It is ready for use and high on my list to test out. Okay, cool. So I'll be testing something. Let's go here. Lean Prover Lean Action. Lean Action, CI for lean projects. Lean Action provides steps to build. Yes, action.yaml. Provides steps to build, test, and lint lean projects on GitHub. Okay, quick setup. To set up lean action to run on pushes and pull requests in your repo, create the following ci.yaml file, the GitHub workflows. I think it means in the GitHub workflows. It means in this folder, right? Create the following ci.yaml file in the .github/workflows folder. Do I even have a GitHub workflows folder at the moment? It seems I do not. We can do that though. Name CI on push branches main. Apparently my main branch is called master. Replace main with the default branch on push branches main. Pull request branches main. Workflow dispatch. Jobs build runs on Ubuntu latest. Actions checkout. Uses lean standard action and will default input values. V1 alpha. Usage. Okay. Okay, what's the difference between quick setup and usage? Like, I don't really get that. Uses lean prover lean action v1 alpha with run lake test. Yeah, sure. Lake test. Test true. Build arguments to pass to lake build. Run lake execache get before build. A project must be downstream of mathlib. Lab values are true or false. Okay, I'm beginning to become suspicious that like what this section is telling me is that there are additional things I can write up here that will, because I do want to run like execache get before build. That is something that I do want to do. Yes. Unfortunately, the person who wrote this has not written it with someone who has never set up a GitHub action in mind, so I have no idea how to do that. Examples. Lint the my module and check package for reservoir eligibility. Use it. Okay, no. They've done perfectly. Never mind. So I just have to do this. Yeah, wonderful. Uses, and then I have to put like a with colon, and then I put these things. With test, mathlib cache false. What's the default value for mathlib cache? If mathlib cache input is not provided, the action will attempt to automatically detect. So I guess the point is that it's going to look is going to see that, in fact, I do have MathLab as a dependency, and it's going to automatically know to run Lake Exacache again. That sounds great. So I don't actually have to do anything. Cool. Run Lake build with dash dash w fail. Does w fail? Huh. No, that's just like some argument. This is like fail on warning or something like that. Yeah, I don't want to fail on warning because I have lots of the unused argument linter always like sort of complains at me, but I don't necessarily want it to complain because sometimes it's nice to like provide the name of what the argument would be if it were there, just to like keep things consistent. Keep the action updated with dependabot. Because lean is under heavy development, changes to lean or lake could break outdated versions of lean action. Configure dependabot to automatically create a PR to update lean action when a new stable version is released. Here's an example dependabot YAML. This seems like very complicated. So like we have like an action to update our actions. We're like, okay, well, everything is being handled by the computer. Very nice. Okay. So let's follow the instructions. .github/workflows/ci.yaml. No, not here. .github workflows ci.yaml. GitHub workflows ci.yaml. Create the following. Here it is. Save this YAML file. Close. Cool. Add CI. Commit. And let's sync those changes. Now, presumably it won't work now, or it'll like work trivially because currently my foo.lean file does not contain any actual thing other than like a hello world. Hello world. Even so, it would probably be prudent at this point to take a look at what is happening. Formal. This one. Yeah, I should probably add a README as well. We just added CI. How do I? Yeah, that's totally wild. You never see complete lack of yeah, hexadecimal, whatever. Yeah, I've added CI. Does actions 0? There are no workflow runs yet. Okay. I mean, runners, yes. I mean, I do not. I do not like have runners. I'm not like a company. I do not possess runners. Attestations. Attest build provenance. Learn more about GitHub hosted farms. GitHub offers hosted virtual machines to run workloads. The virtual machine contains an environment with tools, packages, settings. Do I have to pay for this? What? I don't really get it. Nice and to do is very nice. Yeah, I mean the like part of the annoying thing is that like I could just rebuild it myself. Is there any details supplied over here? This seems like an appropriate time to potentially ask a question about what CI is supposed to do for me. Okay, can I search for like lean action? Lean upgrade action. Okay, well here's Austin Lutson. What is this? May 3rd. I attempted to make lean upgrade action work for lean 4. I don't know how to test it. Could have CI as an action would be worthwhile. Lean 4 issues. Something is better than nothing. Composite action. Learning so much. What is a composite action? Creating a composite action. Create and use a packaged composite action. And then goodbye. I guess it's just like an action, you know, like action that does two different things. Two, like, does one action and then some other action. Composing actions together. Python. Update action. Right. Doesn't support passing options. Standard entry point. Right, the thing that I was like sort of expecting. Go to MATLAB 4. I get to see this nice little check mark. All checks it passed. Continuous integration, sure. So it would be nice to be able to see this. My own thing. Lean upgrade action, lean action, lean upgrade action. GitHub actions. Yeah, not. Here's my action running. This is like the trouble. I have actions. Okay, it's a CI, right? Yeah, this one. This workflow has a workflow underscore dispatch event trigger. What does that mean? Copy, search. This workflow has a you can run a workflow that is still in development. For actions working on a third party, I would like to be able to create an action on and execute it on the Workflow dispatch event. I don't know what that is. Run the workflow. I'm just going to try this. Workflow run was successfully requested. Okay. Is there something, wasn't there something in it where it's like, yes, on push to, oh, okay, I'm dumb. I'm a dumbass. I literally read this. And was like, mine is named matter, but then I literally did nothing about it. Okay, so workflow dispatch. Okay. So this is now in progress, actually. Okay. We're just going to make a quick commit here to say to master ci.yaml. So that's fine, but we're not going to quite yet push that because we just want to like see if this one runs without being interrupted. Is there a way? Okay, so build. So it's running build. But in theory, okay, but yes, returning to like the first thought I had when I was starting all of this, in theory, build should not be doing anything here because there's no, because the contents of formal SNARK's project.lean are empty, which makes it a little bit mysterious as to why, okay, this took a while, but it did eventually complete, completed in failure. Why did it fail? No test runner script or executable. Run lake test. Okay, so it attempted, so it ran lean prover, lean action v1 alpha, yes. What it did is it synced the repository. It got the git version info, clean the repository, checking out ref, run actions, run detect mathlab. Project is downstream of mathlab. It detected that correctly, and then it ran lake execache get, which is excellent. This is what happens when you run lake execache get. Downloaded around 4,000 files, 100% success. Then it ran run lake build, and presumably it didn't do anything because it just had a formal SNARK's project thing it didn't like, wasn't anything in the file. And then run actions cache, saved something into some sort of cache of some kind. Maybe this has to do with like how the caches get created, like from mathlab. And then it ran lake test and it realized that there was no test runner script. Right, so the key question now is the better thing for me to do now to delete the testing capability, or is it to try and make some? I feel like there was like one thing where I was like testing something, right? I had like a little soundness prover test.lean file. How does testing work? I don't know how. Yeah, see, this is one thing I'm totally unfamiliar with is how lean code is usually tested. If I look here and I look in the test directory, there's tons and tons of little files. Okay, I'm going to take a quick break and I'll be back. Okay, well, looks like my audio is working. Wonderful. Okay. So, CI failed. Run like test. No test runner script or executable. There's no test. Run lake test. Okay, what happens if I run lake test like this? Lake test, does this work? No test runner script or executable. So yes, that's the error message I'm getting. Question is, what format does a test runner script or executable have to have in order for it to be recognized? If I look at MATLAB, script, is there such a thing as, okay, if I look in the MATLAB, the place where they define all the executables, which I think is the lake file. Right, so they definitely have cache, longest bowl, archive. It's in the scripts directory, so they have all these executables. Nothing about testing, though. Is there like a top-level thing called test? Giant element of PQRST. No. Test. Yes, how does MATLAB test? In the scripts, feels like there should be something about running the tests. Line import, benchmark, check YAML, check silent, fix by line breaks, fix comments, fix line breaks, fix lints, install Debian, install macOS, in PR testing, comments, lint bib, lint style, lint hash commands, make port status, no loss declarations. None of these look like a test runner, something that just runs the test. Lake test. Make test -- help. Looks for a script or executable tagged at test runner in the workspace's root package and executes it with args. The workspace's root package. What is that for this one? Mavlive.lean. What is it? At test runner. Let's search the repository for it. Huh. Your search did not match any code. Mysterious. Looks for a script or executable tagged at test runner. What does it mean for a script to be tagged test runner? Is that like a GitHub thing? If I look into the is there some place where build. Is this where tests are run? Build, is this where tests are run? Test MATLAB. Test. Okay, well I think it's just the case that this is an entirely different testing setup. Looks for a script or executable. Executes it with args. I just want to like build certain files, you know? I guess we're just going to, like, the whole point is that the things that we're building can be built with build, so why not just ignore this? Okay, let's just ignore it. Yes, with test false. Lean prover lean action v1 alpha with, okay, we need the YAML file. Let's close this. Uses, I think the width is at the same indentation level as the uses with test false. With test false. Sure, default is true, but I want it to be false. Cool. So now that's changed. So, yes. Turn off test. Commit. The other thing that we wanted to do was go to the top level. Forget about this. Let's import. What we want to do is import some like sort of low-level file, polynomial quotient. Okay, this one doesn't import anything else. It builds fine. Formal SNARKs project to MATLAB polynomial quotient. SNARKs project dot to MATLAB dot polynomial quotient dot lean. Sorry, polynomial quotient. Imports that are out of date. Yeah, can I restart the file? Maybe. It's going to build up to that. It's going to build that, and then it's going to say that everything here is okay. Cool. So I'm going to do like add import to what is the name? It's like I can't just keep calling it the foo.lean file. I want like what add an import. It'll be obvious. Okay. So we changed 3 things that we've done. We've changed it so that it's on or let me like increase the volume a little. We've changed it so that it runs on push to main or to master, or whatever it's called. Runs on push. We have turned off tests, and now we have it importing something. So now it will at least try to do some building of things. So let's run the sync. Now that it's a sync, and now that we've added to the actions, right, to like run on, so that it will run when it's, pushed to, and we just push to it. I think that means, I think that it's gonna go automatically this time. I'm not gonna have to manually build it. So here, pending, cool. So this is good, yes. So I added an import and now it's pending the test. CI build, very good. Yeah, lots of things can be. be added to this. Like add a README, maybe like brush up this little about section here. Check is in progress. This is good. It feels like it's running. Like let me click on it. Let me see what the details are. Build succeeded. Okay, did it succeed? Yes, I have a little green check mark. Huzzah. Very, very excellent. Okay, cool. Oh, look, there's Alok in the like comments here. Wonderful. I'll join in like an hour if you're still up and at it. Okay. Well, we'll see. We'll see if I've like accomplished the main things that I want to accomplish by then. But if so, then sure. Okay, so the thing that we accomplished just now is that we added a single import to this file, which is what we wanted to do. But what we want to do now is add lots more imports. So basically, like just going to peruse. This is a bunch of like things that don't actually provide models. Right. I think that, okay, so here's mainly what I would like. I would like everything in the 2MATLab folder. So I'm going to put those down. Option, equiv, right. Holonomial, sorry, 4 transformations. Cool. All of those seem happy. Another thing that I would like is the actual transformations thing. So import transformations. That's a little bit dumb as a naming convention, actually. I should probably change that at some point. Transformations. The other one I want is import models AGM per system instantiation. AGM proof system instantiation AGM. Imports are out of date. Okay, what happens if I run this? Now it's going to build all of those things. Apparently, I forgot models. There needs to be a .models here. Yeah. Okay, but it looks like it's totally happy. Just recompiles everything. Yes. All right, good. So let's add more imports. Add imports. And then we'll push that again. Formal starts project dot. Yeah. Okay, so lots of different things. Excellent. So all of that is present. Simply I can refresh, and of course it's pending. I haven't given it anything really serious to build. Problem is I can't necessarily. Well, this is where I would like to know about who is paying for the compute I'm using when I do this. Because in principle, I could add some snarks to this too, but that would really increase the amount of work that the runners are doing. CI. No, I want like things that I have sent to do with CI. Like update. Right, copy and paste. More appealing. All right. I feel like this is not necessarily the right thread to do this in. Is there a thread about lean action? Well, lean upgrade action is not exactly the same as lean action, right? Hmm. This feels like a lean 4 thing. Like more than anything else, I mainly like to just ask about like lean action. It was recommended to me that I use. Okay, sorry. Oh. Sorry. Message is sent. I'm gonna just link things. CI. What's here? This is where it was recommended. CI. Right. Copy link to message. It was recently recommended that I use this. Sans serif lean action to CI my lean project. This seems to be working well. I mean, like, it's the case that I succeeded again, right? No, sorry, this is MATLAB. Where was I? Here. If I go here, I refresh. Yeah, I've got a little success check mark. Kudos to the author, Austin Letson. Letson. have a few questions. Maybe this would even be better for this would be a little bit better for general, actually. I don't like general lean 4. What's the difference between general and lean 4? It's literally the lean forum. So everything in this thing has to do with lean. It's like, I guess if it were lean 3 related, you would put it in general, but whatever. I guess lean 4 is more for like specific things about the language development. So yeah, sorry. I'm going to paste this here. I'm not going to post this here. I'm going to put it in general lean action. I have a few questions. Who pays? Yeah, for the computer to run this action? Is there a limit to how many times I can run it per month? Second question. Is there an example of a repo with testing set up so that I can get testing to work? The other question, I feel like I have one more question. Right, the other question that I had, these questions are good enough. It was Kim who recommended this. Last time button, we're making it. Cool. All right, seems good. Let's see, what else can we do? Are there any other files we can include? Basically, proof system instantiation is one that I included. Okay, so I did have an idea. Is there any like, I don't think there's any like actual content in these files, most of these files. One thing that could potentially be done is I was thinking of reworking everything to be in like type 1 versus type 3. I mean, okay, like, so one thing I was thinking is I can make a pull request for this. Okay, yes, right. What I want to do is say what's new in this one, because I want to see, right, toAdditive is making something here. Oxlemma, oxlemma, oxlemma. Prod map eta eq prime. There's also going to be like a sum thing, no? I don't have any idea what is going on. Why is this such a massive? Is this like a elaborated tactic thing? Tactic mode is gone. Yeah, full crazy here. It doesn't show me the thing that I wanted to see though. That's a little annoying. I mean, okay, so what I was, yes, just as a demonstration of what we have here. So I have this, and I was thinking I should make a pull request for this. But before I make a pull request for this, right, the point is that like this should now technically be provable. Like rewrite some map this thing prime. That is what I want you to rewrite with. It looks very similar in many respects. What happens if I call simp? Simp just dispatches it. Very cool. Okay. This suggests to me that I could probably make this. Right, the point is that there's another file which uses these, which is this one. Here I use list map et. This one. Okay, so the point is, yeah. Okay, the point is I have this and then I do this. So I want to get it to the point where like I was able to simplify and then it just went away. So what happens if I add the little prime here? Okay, it's totally happy. And if I do the same thing here, simp. Yeah, this is much better form. Because it doesn't involve a cast, right? My new version. The nice thing about this form with respect to this form is that this one, yeah, uses like an n small or whatever that's called. It uses like the tau is transformed to n small. Yeah, it must be pretty smart actually to transfer the tau to the n small there. Two additive is a very powerful tactic. But I think the main thing, right, this is all additive, and the point is that it's I mean, I guess part of the point is that this could be like add com group. What does this take? Add com group, yeah. Interesting. Well, the point is that this is not needed though. So let's just delete it. And delete this. And if we go back over here, we can delete these as well. And one thing that we want to probably do is restart the file so that we rebuild everything. Okay, so that's very good. All of this seems totally good. So I'm going to make a pull request just to say that I've done this, which is like, okay, to additivize, what's the What's the thing that I was doing this for? This one. Divide devise this. Can commit that. And then, of course, the other thing to do is simply to pull request this to MathLab itself. So let's open up a MathLab window. Here is that. Let's go to master. Synchronize. Okay, so which file should this go in? Ring theory polynomial basic. I have no idea which. Where should this go? Like list count cons. This is in batteries. MathLab, okay, here we do have a MathLab dependence. MathLab algebra big operators list basic. Yes. That seems appropriate because it's about a prod, right? It's about prod, so this does seem like an appropriate file. Let's copy this. It's called algebra big operators list basic. So let's go to list basic. Sorry. Am I insane? MathLab algebra big operators list basic. MathLab algebra big operators. Is the issue that I'm out of sync? Is the issue? No. The definition for this. MathLab algebra big operators list basic. Okay, we just need to, obviously it's been moved. What we need to do is figure out where it was moved to. Apply before docs. This one seems right. List dot this. MathLab algebra big operators group list. Big operators group list. Okay. Because it's a monoid, I guess. I don't know if I am a big fan of that. That's such a weird place for that to be. But I guess it's fine. So returning to the topic at hand, what we're trying to do is make a pull request. Let's copy all of this. Prod cons. Find prod cons. Prod underscore cons. Where is it? Like prod, all of this stuff. This feels like something appropriate for the end of the section. Thing here is too additive. Like right here. Let's restart lane. Watchdog error, got a shutdown request. Okay, do I have to like build cache? Let's get the build cache. Oh no, cannot fetch MathLab build artifact cache. This is why usually when this happens. Okay. All right, let's just revert everything. Okay, now that everything is reverted, let's do that. It's not happy. Can we move this to something called trash? Okay, let's try again to fetch the gold cache. Just in. Right. Yep, gonna download a bunch of files. That seems like it's going fine. Okay, so obviously one thing to notice is that we are in the list namespace, I believe. Yeah. Therefore, it is not necessary to have .list anywhere. I believe. Okay, cool. My function compiled as well. Glorious. Now we have gone one line too many over there. It does have to be a group for this. Are we in like a monoid section? Common monoid. Obviously we are in the monoid section, so it would be better to be in the group section. That could be possible. Now the folder is called group, so you would think that that would be possible. We're in the com group section, in fact. Let's go to the com group section. Put this here. So com group G. So let's delete this. All the B's can become G's. A is a type with definable equality. Otherwise, it seems fine. Now let's just look quickly. Yeah, okay, I've got to put things in the correct style. Prod map this. Okay, so a further observation is that we can write prod map ite, yes. But there's another way of writing it, which is L dot map. And another way of writing it, which is dot prod at the end. That seems fine. You can also do L dot count A and L dot map G dot prod. Yes, just dot notationing it up. Okay. Is there anything else that I'm missing? A is a type with decidable equality. I think that's fine. Like it is, in fact, necessary for this in order for that to work. We have a list of A's. Maybe L should be first, I don't know. Maybe let's do the L first. Okay, so that seems fine. Let's like further make sure that we see if there's anything that can be golfed here. Right. I mean, I like this format. Is it possible to include all of this on one line? Not without the by going over. So in that case, I like doing the multi-line equals. Okay, is there any way of golfing it? Like in theory, I think this is a golf. So what do I do here? I rewrite all of these things. Rewrite using the inductive hypothesis. I wonder if I can like include this here. Delete this from this. Oh, sure, that seems fine. And then I do some very nice rewriting. Should really be much easier than all of this. I mean, theory, I suppose I can delete this. But like this does not work because I need to do these two things separately, I think. Can I combine these? That seems to be fine. Okay. Obviously I have a simp here. Apparently this needs to be present. One, yep, that seems fine. All that seems good though. I'm perfectly happy with this little to-do because that should in fact be done by Yep, looks pretty good. Don't think it should be a simp lemma. Okay, why don't we create a new branch, prod map unique. Enter. Okay, so it's here. I'm just gonna open this file up, right? And then I'm gonna add this. I'm gonna say add lemma. I'm gonna commit this, publish the branch. I'm gonna mosey on over to MathLab GitHub. This one, where it will tell me that I've opened a pull request. Feet, add lemma, prod list. Link. lemma from my project. Cool. Seems great. Pull request. I think everything is fine. We can just mark this as waiting CI. But that's very nice. Oh, and we can also copy and paste this. Okay, so cool. We've done our MATLAB pull request. And what we can do here is we can say, yo, we have done this. In fact, let's put this link here. Okay, so this link is now exists. Seems good. You could also maybe try to pull request these. What is involved in these? Right, these are just sort of like simple lemmas about multivariable polynomials. Oh, who really knows? Like these two. Now the question is, are they simple lemmas? Are these the kind of lemmas that people would say we should be simple lemmas? The answer is potentially not, because people don't really like making if then else simple lemmas as much as I do. But maybe they could still be added. One observation. Also noticing a lot of like simps rather than. Right, this is maybe a good like, yes. I was burned not in the not too recent past by a bunch of non-terminal simps. So maybe something good to do here. Wait. Just do a whole bunch of these. What happens if I add like a question mark everywhere, all throughout? Huh. Well, that was a major fail. We're doing simp only, so that should be fine. Yes, the reduce ite simproc. Wonderful. This is the thing that tells you to like simplify the main thing first. Oh, there's one more. Did the thing that it contained? This maps out. No, it just added some other things. Okay, cool. So I'm going to say about this file that why is it not? Okay. In this file, what I've done is to remove non-terminal simp. Commit that. This file ref to MATLAB PR. That sounds great. Okay. Yes, making progress. Yeah, XPAL is monomial. Obviously, this is present because it's used elsewhere. Yeah. Such a complicated proof of this theorem. These lemmas don't use this one. Coef monomial is probably the key lemma here. F5 algebra and be polynomial basic. Let's see if I can add those two. Okay, so let's go back to master. Coef monomial. Yeah. Okay, and be polynomial basic. Algebra and be polynomial basic. Coef monomial is the name. Yeah, it seems like this would be the place. But these guys have simps on them, so it seems not unreasonable to try and add more simp lemmas like this. Artifact cache fetched successfully. I don't know how this type u_1 got there. Let's copy these. Okay, so we have coefc. This is the section where we speak of all of the coef. How to take coefs of things. Coef. And coef. This talks about how to take a coef of a monomial. This talks about how to take a coef of x. Coef of x mol of x. Seems like approximately here is where it should go. Okay. So I think this is fine. R sigma are already declared, and all of the things that we probably need to know. What are them? Decidable eq sigma is something we probably will need. But we can delete these other things. Namespace duplicated, yes. So let's delete all these namespaces. Cool. Looks like we're doing okay. Okay, now let's just think a little bit. Fins up single jn. cof r equals r. Yes. You have to be informed of the because if we to remove this, it all goes to. Oh, really? Huh. No, that's not right. That's very weird that it chooses natural numbers for the anyway. Jn. Okay, so let's just try to adapt this a little bit to the way in which things tend to be written. I think that instead of x, it seems a little bit more common to have s be the sort of terminal. xs, s, instead of dot single, a, b. Why not just use dot single, a, b? Why not just, okay, j and n can be a and b maybe? It feels a little, n feels a little better, right? J, okay. 1 equals 0. I simply write this. Congruence. Seems like a solid proof to me. Let's do the same thing over here. Again, rather than x, let's choose s. S, s. Interesting. We can delete this. Presumably, like, FinSub is open. It would be cool if Tado would identify this. I guess it's fine. Always good to check if, like, you know, everything seems to be necessary. Another observation is that up here, I was able to move this to here. Right, so I basically so really have to be single equals single. Can this just be a rewrite? Yeah. Can this just be a rewrite? Interesting. Well, this all seems basically fine. Yeah, interesting. So I can't delete that though. There's a little dot in front of it. Not sure if I'm a fan of all of that. I think this is a little better. Okay, this seems great. So what am I going to do now? Clearly, I'm going to change branches. Cof single x. that new branch. In the new branch, I will open the file. I will add the changes, or stage the changes. Lemmas. I guess I'll publish the branch. Brush over here, hello. Go back here maybe. Eat, add lemmas, out. This substitutes some lemmas about coefficient. Coefficient, single on s to the n. Sure. And then one way, like, so an additional, I haven't, like the other way of thinking about this is like potentially another way of doing this is that, right, like this, you could say that not complete things. Like potentially slightly golfier. I don't know. Does anyone really care? Slight golf. Either way seems fine. I'm going to assign the label awaiting CI. And very good. Okay, so yet again, I'm going to copy this and I'm going to go back to where I was. I'm just going to put a little link. Ref, mathlib, PRs. Sure. I wonder how you get it to, I wonder how you get CI to complain on like lines that are too long. I don't know if that's something I want to annoy myself with, but it would maybe be interesting. None of these two are used here. What is this lemma? Is this lemma like more cleanly interpretable as something? I don't open any namespaces in this file, which is maybe somewhat appropriate because it's basically all destined for MATLAB. What is that? It's a multivariable polynomial remove. Sample removed. Yeah. Now the strange and maybe a little bit bad thing here is that what does this actually have to do with polynomials? There's nothing to do with polynomials. Oh no. We have something about polynomials here. Let me like try and read this. Right, so this is all for this sort of transformation where I replace one thing with another. X sample removed equals 0. Right. If I find, okay, where is this used? Find, it's used down here. Right, the key, the point, filter, sample removed, X support. Yeah, wow. I mean, this entire file is now sort of written in such a complicated way that it's going to be like hard to even sort of parse out. Like for example, this one doesn't depend on this one. This looks like a slightly cleaner. And the next use is on line 240. I can like move this forward. I can think about trying to upstream these. The thing is, okay, there's something, okay, I like coming back to this file, at some point I learned if I go to a docs page, there's something called MV polynomial replace. No, is there not like a replace? Rename. It's this one. MV polynomial rename. Rename all the variables on a multivariable polynomial. What is kill compl? This is another. Yeah, rename. I sort of wonder if there's like some way of rephrasing a lot of this stuff in this file. Do I mention rename at all? No, I don't. And I wonder. The thing about rename is that I'm not sure that the operation that I'm doing is exactly renaming. What I'm doing is sort of replacing one thing. Sort of like I want to like form this sort of injection between polynomials. It's not really an injection though. It's like an injection on the type of polynomials. It's like, it sort of invokes the degree bound. Wait, I just moved the wrong thing. Wait, undo. What I wanted to move was this. Not MEMS board of degree of. So now, yes. So now we are in more reasonable territory. Yeah, let's look at like this shorter lemma that seems to be a more reasonable lemma and try and figure out what's going on here before we like port things to like try and like extract to like do the squeezing of theorems, which will be harder. Prod not equal power of monomial. Okay. FinFET dot product. Yeah, again, I feel this is just yet another one that's just sort of used once in a very obscure way. Point is, if we take x.support, it's always weird that there's not any, like, yes. I mean, like, okay, here's maybe the cleaner way of saying it. If I have some finitely supported function, and for every, yeah, I do this, I do finsub support. I filter out everything in the support. Y sigma. I filter out everything support. Right, so finsub support gives me a bunch of sigmas, right? And I'm going to filter out everything that, I'm going to filter only those things where y is equal to sample removed. Wait, filter out. I filter out everything where y is sample removed. I filter out sample removed. And then I take the product of that. That's the same as just erasing sample removed from that monomial. See, like, there's potential that this could be sort of like put in reverse. Question, I feel like maybe sort of what is going on is that I don't have the right x pow equals monomial. Coefficient a and exponents given by us. Is there any name for this thing, that the function that the monomial that where the coefficient is always 1? I guess not. There are ways you can write this in a more, like, start that process. X the support filter these things out, and then I take the product. It just doesn't feel like a clean theorem. It feels like it feels like I shouldn't be working. I shouldn't be like going down to the abstraction of finitely supported functions. I should find a way of expressing all of this in the language of multivariable polynomials. Like, what am I trying to say? If I take a monomial and I erase one sample, if I have a yeah. That's what you get from constructing all the other things. Okay, this one is like just way too simple to not exist as a theorem already. Exact. Okay, it does exist as a theorem. What am I saying? Okay, let me read this. Simp. Coef mv equals 0. Right. Right. The point is that like, okay, what is the usefulness of this? The usefulness of this is that it's a simp lemma. Right? If m is not equal to p, if m is not in p support, that's equivalent to the coefficient of m and p being 0. But if that is the case, we should simply rewrite. But like my only motivation here is like making this a simp lemma. Question is, does this exist in some other form? This itself is proved by simp. Then support if. Right. Okay, but if I touch that, it's gonna get so mad at me, so I'm not gonna do that. Yeah, it's a little lock here. So that I'm not tempted to do that. Support coef. Yeah, it seems nice to have this as like a simp lemma. Is it proven by simp? This feels like a totally reasonable lemma to have. Because it's nice to have it as a simp lemma, right? If it were just going to be the lemma, then it would not make sense because anything that you could do with the lemma, you could just do by invoking this thing. But the simp is nice because this way simp will trigger on it. So that makes sense to move. Okay, so I'll try and do this moving. Yes, let me try and move this. Okay, let's go back to master. This is, again, mathematic algebra MP polynomial basic. Not support if. There you go, back to the top. And all I want to do is add a simp lemma. Of course, I don't need this. It's not even, okay, lots of things going on here. R, of course, is the identifier of choice. It was not necessary that it be a field. It was probably only necessary that it be a Kahn semi-ring. Why is it necessary? Is this? That was also not necessary. Yeah, just totally unnecessary, this. Interesting. Yeah, what is the point? What is the point of making like making implicit variables? It's like it should only. What is the point of making implicit variables? I guess the point is that you like will have something of this form and you'll want to apply it. Okay, all of this seems fine. We can put this here, and that's not going to fit, so that goes on its own new line. I think that it will want it in the form of this, and this seems to be matching what we have above. We can also delete the by exact probably. Save that. Seems fine. I think seems good. Point is that we're adding this as a simp lemma. I'm going to add that. Okay, wait, no, I don't want to stage that on master. That's not what I want to do. What I want to do now is create a new branch. Create a new branch. Copy that, create a new branch. Branch's name will be seems like a good branch name to me. Go here. Can add this. We can say add lemma. Commit. Publish branch. And we'll return over here. Math54. Parent pull request. Eat. Add. Simple this. Simp. Adds the forward direction of right. Yep. As a simp lemma. Create pull request. Wait CI. Seems good. Cool. And of course, PR reference. Not mem support of degree of. Okay, what do we got here? Yeah, field is not necessary. Okay, P is a polynomial. Degree bound. Like HD should not be necessary here. Right. The point is that if the degree of the sample target in P is less than D, and the degree of this, what? And M is a monomial, it's sort of written in a contrapositive way to state it. Let me see if I can state this lemma in a not contrapositively, right? Like, what the heck? Unused variable. It's used right there. Okay, so what I'm trying to do is flip this around. So I want this to go here, and I want this to go here. Nope. Undo, go here. Should be not in this. It should be like mem support. And this. Why is the unused variable linter? Can I restart the file? Okay, at least that works. I'm not going to try introing something. I'm going to do that. Apply. I want to apply H degree. Can I not just apply? Oh, like this? Exact. I'm not going to support this. I could be doing this. Going to show term. Yeah, I need an M there. Otherwise, it's fine. Okay, this is a 4-line proof. And my contention is like to do like contrapose this. Exact. Okay, and sorry, the name should now be degree of mem support. All right. I mean, the real question, HT. When is that HT should not be necessary? Okay, if I delete this and I say have HT 0 less than D, it's going to be like this, Linerith. Cool. Linerith? What the heck? This is like let's delete this. This is now possible to delete. At some point I will get an error because it will say, oh, look, HD was not needed here. And then it'll be fine. And just to double check, we'll make sure that nothing in this file got warped by that change. Seems like it's fine. Did I restart the file? Let me run it one more time. Cool. Okay, so now like further observations. Okay, so what I sort of want to do here is not like, just want to inline this, contrapose sample target bound. Now I want to do exact question mark. So that's fine. Now we can delete the negative version of this. Cool. So that happened. And this is complicated enough, perhaps, that it makes sense to put it in its lemma. So let's do that now. Yeah, well, the first thing that we're going to say, what the heck? Yeah, sync changes. Sure. Add. Draw positive vibes. This one commit. That's fine. So we've contrapositived it. Why is it? Yeah, cool. And now we want to proceed. I mean, the real question is, multi of LT something h degree. Does this exist? Okay, so this is an even shorter proof. I can even like show term. Yes, the question is there really any point at all? Why not? Right? There are two applications, right? The point is that I can simply do this. Not just be like a really long exact statement. Monomial LE degree of. Yes. Right. Seems like a good complaint. Why isn't that lemma sim tagged? Seems like a great candidate for sim tagging. I feel like if people don't like sim tagging things with. Interesting. Okay. Should I just delete this whole lemma? The thing is, I have to inline it, right? Lemma sample target value. What happens if I show term this whole thing? Okay, well, contrapose is not friendly. Now that that's gone, this whole thing can just be deleted. Okay, cool. It's sort of annoying that this staging, something is broken in my source control. New inline lemma. I wonder if anyone has responded to my question. Probably not, because it's super late at night. Okay, anything else? This is always a little sort of awkward. It's like, is that all? Fine. It's needed in 3 places. I felt it necessary to do with this. What happens if I delete these? Tactic failed. Okay, well. If I have 2 natural numbers, then if I cast them individually to integers and take their mod, It's the same as taking their mod individually and casting into an extra. Okay, like for one thing, clearly this is impossible. Let's try and yes, totally fine. And if we do this, that's fine too. Okay, like I further was able to do this. So HA mod ink of LT. Seems like that might be necessary. Yep, seems fine. Yeah, and then we get into like the monster theorems. Yeah, I'm not totally sure what to do about these. Because it gives me the like one thing that I need, which is this. Bind that. Yeah. Yeah, the problem is I don't know how to prove this in like monomial terms. Or NP polynomial terms. Ugh. Okay, but this can be like what? Yeah, what's the more like what's the better way of writing this? The better way of writing this is not to include an equals here. Let's see if I can do that. Near mods. Okay. Near mods. I have those. Yeah. So I'm using it in some weird way. And the better way of writing it is to remove this, and all instances of A get replaced. What am I there? Near mods prime. Delete A. I'm gonna get this. The facts that we have are that B plus C times D is less than that. Yeah, it's like, is there a way of proving this? Okay, like the first question, is there a way of proving this? C is a Z. Yeah. A is a natural number. C is an integer. So this whole thing, so in some sense it's not, right? The thing is, like, it only looks this way. It only looks as if we have this, but the reason this is valid is that this is actually, in fact, something where we've cast C to something, A to something else. What's the better explanation to this? Like, in theory, we could just, like, this is like totally, everything here is like some linear thing, right? What we could do is we could say, like, okay, A prime, B prime, and D prime are all the, like, are all the Z's. We would have that all of them are at least 0. A would be less than D, so B plus C times D would be less than D. C, we don't know is equal to 0, but we're trying to prove it. It just seems like it's an appropriate thing. Maybe it's like more appropriate to state the whole lemma for ints. Right, because if I conceptualize it that way, it's like I have these integers, and A is equal to B plus C times D. The point is that B is less than D, so we can't be controlling that. And that A is less than D. Yeah, the point is that the point is that B minus A is less in absolute value than D. That's the sort of interesting thing. Let me see if I can rewrite the whole lemma in terms of I'm going to call it int dot nearmas everything. Okay, let's make everything an integer. A, B, C, D, they're all integers. A, H, A prime is that A 0 less than A. Yeah, cool. Except that I don't want it for C. Right, how do I go about proving this? The way that I would go about proving this is I would say something like I would say something like B minus A is strictly less in absolute value than D. If I have this, if I have that statement, then it feels like I'm Is this even true? Did I make some mistake? Maybe. Okay, this has to be C. It's primarily what I'm interested in. A mod D equals B mod D. At mod eq of LT. Right. So can I not just say something like rewrite this HA at H? The problem is that this is for nats. What we need, okay, here's what we need. What we need is if A, B, and D are ints, lemma, if A and B and D are ints, I don't know what n is. The point is that if HA 0 LEA, HB 0 LEA, I don't think that's, what do we need? A and B are both, no, I just want A actually. I don't want that other stuff. I want A and D, 0 is less than A, and D and A, HAD, A is going to be strictly less than D. The fact I want is that A mod D equals A. Foo. Is this exact? E mod eq of LT. Here for integers, yes. Cool. So this exists. So let's shut this down. Rewrite HA prime at H. Should be able to do it with HB prime as well. A equals B. Temp H at all. Unsolved goals. What? B is less than D. 2 goals. B is less than D. Exact HB. J. I don't know what is going on. And clearly we can prove this, so okay, yeah. Apparently we did not need the D assumption. Cool. We do not need the D assumption. That sounds fine. Okay, we just need to like, yeah, this is a valuable comment. We just need to put it somewhere else. Just save this. My file. Okay, that's saved. Great. What else have we got? Right, so, okay, but the thing is, now that we have this, it's definitely in a form where A needs to be completely removed from the equation. Definitely need to remove A from the equation completely. Is that we use it down here. Bunch of naturals. And getting things getting lifted to Z. What is that? And then there's an application of near mods. Near mods says C is 0. Yeah. I wonder if there's something like int absly mole self. Int abs lt absolute value of this mole self. Then, well, that's not quite it. Equals 0. Right, this is close to what I want. If m and x are z's, and m divides x, and x is of less than m, and x equals 0, this is really the theorem. Like, yeah, so like just to like prove this yet again. Transpose C is equal to 0. C is the multiple b minus of a minus b, right? Sorry. What is the, okay, can you just show me the x? Can you just say that, like, please, that x is equal to this? My word. It's totally fine here. What the fuck is the problem? 1 divide c. How do I subtract both sides? Have a minus b equals times d if I rewrite, right? Yeah, well, sure. Who knows? To do reprove with this question mark. All right, that seems like good enough for one night, perhaps.